Auzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Hello my students. Welcome to the last period of physics e-note class for this week. My name is Oladimeji T.A., the SS2 physics teacher of CTY Model College, Ibadan. Today, we want to look at progressive and stationary waves. So far, so good. Under this topic, waves, we've treated definitions of waves, types of waves, and graphical representation of waves. In the last period we look at properties of waves, where we look at reflection, refraction, diffraction, interference, and polarization of waves. Today, like I told you, we want to look at progressive and stationary waves, and this is going to end our discussion on waves. A progressive wave is a wave that travels and continues to spread out from the source of disturbance, while a standing or stationary wave is a wave that is produced when two waves of the same frequency and amplitude superimposed or overlapped. The superposition of two waves of the same frequency and amplitude that are exactly out of phase leads to the formation of a region of zero resultant disturbance, as shown in the diagrams below. Let's look at the two diagrams. In this first diagram, there are two waves. The wave in red color and the one in blue color. So they are superimposed and they are in phase. So the wave produced is a wave of double amplitude. So this is a kind of constructive interference, and the kind of wave we are going to get here is a wave which is going to have double the amplitude of each of the waves that are superimposed. Remember, the two waves, they have the same frequency and the same amplitude. So after the superposition, the amplitude produced is going to be twice the amplitude of each of them. Let's go to the second set of waves. Here, the wave in green and the one in black, they are out of phase. So when they are superimposed, the trough of one falls on the crest of the other, and they eventually cancel each other out, and they produce zero resultant. This is a kind of destructive interference. Stationary waves. Stationary waves are obtained as a result of the combination or superposition of an incident wave and its reflected wave, which is of the same frequency and wavelength and are exactly out of phase. Thus, the crest of the incident wave coincides with the trough of the reflected waves. And vice versa. The diagram below shows two notable points on the stationary waves. But before we move to the point, let me explain further on stationary waves. A stationary wave is formed when an original wave is reflected and its reflection is combined with itself. We have a standing or a stationary wave, and the two waves that can produce a stationary wave must have the same amplitude, same frequency, and same wavelength, and they must be traveling in opposite directions. And the two notable points on the stationary waves are nodes and antinodes. A node is a point on the stationary waves where there is no movement of the medium at all, while an antinode is a point on a stationary wave where there is maximum displacement of the medium. Let's go to the diagram of a stationary wave. Look at the waves. The original wave is the one in red. It travels towards the positive x-axis. On striking the barrier, it is reflected along the green path in the opposite direction to its original direction. And when the two waves are combined, we have what we call a stationary wave. You can see the crest of one falls on the trough of the other, and we have a stationary wave. And all the points on the horizontal line, they are known as nodes, while the point of maximum displacement on both red and green waves are called antinodes. And we've defined both. Now, there are some things we need to take note on the wave. The distance between two successive nodes or antinode is equal to half of a wavelength. Also, the distance between two successive nodes or antinode is 1 wavelength. Sorry, that number 2, it is the distance between 3 successive nodes or antinode is equal to 1 wavelength. Take note of that too. The word that's supposed to be there should be 3 successive nodes or antinode. Let me take it again. Number 1, the distance between 2 successive node or antinode is equal to half of a wavelength. 2, the distance between 3 successive nodes or antinode is equal to 1 wavelength. While the distance between a node and the next antinode is equal to quarter of a wavelength. Take note. That takes us to wave equation. The equation of a traveling wave can be written mathematically in form of cosine or a sine function, because when a wave is traveling, the movement or propagation can be represented by a sine graph, because the wave moves sinusoidally or periodically. So we normally use a sine function or a cosine function to represent it. The equation 1 we are seeing on the screen is a sine function, and the wave equation is written as y is equal to a sine omega t minus ks. That first one is when the wave is traveling towards a negative x direction. It can also be written as y is equal to a sine open bracket ks minus omega t. That is when the wave is traveling towards the positive x axis. Then there are some parameters we need to talk about in the equation. Y stands for the displacement of the wave along the vertical direction. A is equal to the amplitude of the wave, which is the maximum upward or downward displacement of the wave from the equilibrium position. Letter W is called omega, and it stands for angular velocity, which is given as 2 pi f. K is called the wave number, and it is given by the formula 2 pi over wavelength lambda. T stands for time, and x is the displacement of the wave along the x axis. Then this can be transformed into this equation 2. Y is equal to a sine. I told you that W omega, the formula is 2 pi f. So when 2 pi f is substituted for W, we have this. A is equal to a sine bracket 2 pi ft minus 2 pi x over lambda. Remember, k is equal to 2 pi over lambda. So we've substituted for omega, W and k. That's why we have equation 2. Then look at equation 3. We can have equation 3 by factoring out 2 pi in the bracket. So when 2 pi is factored out, we have y is equal to a sine 2 pi into bracket ft minus x over lambda. Then equation 3 can be transformed into equation 4 by factoring out 1 over lambda 2. when this is done, when 1 over lambda is factored out, I'm going to have this a sine 2 pi over lambda into bracket f lambda t minus x. And recall that v is equal to f lambda, that is the velocity of a wave or speed is equal to the product of the frequency and its wavelength. So therefore equation 4 becomes y is equal to a sine 2 pi over lambda into bracket vt minus x. This is our equation 5. Out of all these equations, any one can be used to represent equation of a wave, starting from equation 1 to equation 2 to equation 3 to equation 4 and equation 5. Our wave equation can be written in any of these four. Now let's look at how we can apply the wave equation in solving questions. Let's look at this example 1. A traveling wave is given by the equation y equals 0.03 sine bracket open 3.5t minus 2.2x bracket close, where x and y are in meters and t is in seconds. We are to find the amplitude of the wave, the wavelength of the wave, the frequency of the wave, the period and the speed of the wave. Let's go. Solution. To solve this problem, we compare the equation given to us in the question with the standard equation. Then the first equation written is the equation given to us from the question. Now let's compare this. If you look at the equation given to us, in the bracket they wrote t before x. That one is telling us that the wave in question is traveling towards the negative x axis. So the standard equation we are going to pick will be the one where x is also negative. That is why we pick the standard one of y is equal to a sine bracket open omega t minus kx. Now if I compare these two equations, I will quickly see that the amplitude A is equal to 0.03. That answers question A. My amplitude is equal to 0.03 meter. I will choose meter because I was told in the questions that the y and x are measures in meters. If we were told that they are measures in centimeter, centimeter will be our unit for amplitude. But because we were told they are measures in meters, the unit of our amplitude is going to be meter. Let's move to B. They want us to find the wavelength. Remember, the formula for K is 2 pi over wavelength, meaning that we can only get our wavelength from the parameter K. And when I compare the two equations again, you can see that K stands for 2.2. So K is equivalent to 2.2 when the two equations are compared. So automatically my K is equal to 2.2 per meter. That is the unit of K per meter. Then changing the formula, writing the formula for K, I have K is equal to 2 pi over lambda, which implies that 2.2 is equal to 2 pi over lambda. Making lambda, that is the wavelength, the subject of the formula, I have lambda is equal to 2 pi over 2.2. Substituting for pi, I have 2 into bracket 3.14 divided by 2.2. Working on this, that will give me my lambda wavelength to be 2.85 meter. I will choose meter too because all these distances are measured in meter according to the question. Let's go to C. I'm to find the frequency. And remember, the frequency for the formula for angular velocity omega, that is the letter W, is equal to 2 pi f, meaning that we can only get our frequency from that omega W. So and from the equations, when the two equations are compared, W is equivalent to 3.5. So writing the formula for W as 2 pi f and equate it to 3.5, we have this. Then making f the subject of the formula, I have 3.5 divided by 2 pi, and that gives 3.5 over 2 into bracket 3.4. Solving this, my frequency is equal to 0.56 Hz. Then D, they want me to find the period, and I know that period T is equal to the reciprocal of frequency. So 1 over F gives me 1 over 0.56, and that gives 1.79 seconds. Then moving to D, to question E, where they ask me to find the speed, and the speed phi is given by the product of the frequency and the wavelength. And since I've gotten the two, I will just need to multiply them. So frequency is 0.56 and wavelength is 2.85. So multiplying the two, I have 1.596 meter per second, which is approximately equal to 1.6 meter per second. Example 2. The wavelength of a traveling wave is 5 meters at a frequency of 12 Hz. What is the velocity? If there is a crest at a distance x is equal to 3 meters at time t, find 3 other positions of the crest at that instance. C. What time later will there be another crest at x is equal to 3 meters? And D. If the amplitude of the wave is 1.5 meters, write the equation of the wave. So let's go. From the question, you can see that we were given the wavelength to be 5 meters, and we were given the frequency to be 12 Hz. So let's pick those two. That's what I did there. And velocity is given by the product of the two, frequency times wavelength. So the velocity is going to be 12 times 5 to give me 60 meters per second. Now, question B. They said if there is a crest at a point S is equal to 3 meters, at what other 3 positions are we going to have crest? Remember, the distance between two successive crests is equal to 1 wavelength. So if there is a crest at 3 meters, the next crest will be at a distance of 1 wavelength from the first one, and the wavelength is 5 meters. Therefore, the next crest will be at 3 plus 5, which is 8 meters. The next one will be at 8 plus 5, which is going to be 13 meters. And the next one will be at 13 plus 5, which is going to be 18 meters. Therefore, the next 3 positions of crest will be 8 meters, 13 meters, and 18 meters. After the first one, which was at 3 meters. Question C. Another crest will appear. They want us to find the time where another crest will appear at that point x is equal to 3 meters. Then, since the distance between the crest and the next one is 1 wavelength, and the time taken to cover 1 wavelength is 1 period, therefore another crest will appear where we have x is equal to 3 meters at after 1 period. And from the question, the frequency is 12 Hz. So to get the period, that is going to be 1 over f, and that gives me 0.8 seconds. So another crest will appear at point s is equal to 3 meters after 0.8 seconds. Question D. They said I should write the equation of the wave, given that the amplitude is 1.5 meters. So from the question so far, the amplitude is 1.5 meters. The frequency is 12 Hz, not 12 meters, sorry, 12 Hz. And the wavelength is 5 meters. So apply this equation. Y is equal to a sine 2 pi into bracket ft minus x over lambda. This is one of the fashions of equation of the wave we have. So the substituting for all those parameters, y is equal to 1.5 sine 2 pi into bracket 12t minus x over 5. So if I factor out 1 over 5, so I'm going to have 1.5 sine 2 pi all over 5. Over 5 is missing there, into bracket 60t minus s. Remember, the last equation is y is equal to 1.5 sine 2 pi all over 5 into bracket 60t minus x. Now, this is where we are going to head our discussion on waves. Please revise all what we have treated in this topic and make sure you have a clear understanding of everything. Questions on this topic Starting from the definitions to where we end it with equation will be uploaded on the school portal. Please, you are implored to go to the school portals and solve all the questions and upload your answers on or before the deadline that will be indicated on the question. Once again, I am Oladimeji T.A., your physics teacher. I'm saying again, Assalamu alaikum wa rahmatullahi wa barakatuh.